Hi, welcome to today's video on material testing. The first thing I want to make clear is that this is just not another video about testing materials. I know there are a lot of videos on YouTube that talk about changing the power and speed to adjust the intensity of the beam that the laser will produce. Although this is certainly one of the most important techniques that you can use when testing materials, there are a number of other factors that can play a role in how your laser works with your laser materials. You need to understand all these factors when it comes to properly testing materials. One other thing, I'm not going to be talking about the color wheel. I'm not a big fan of the color wheel. I think it's a bit overblown. I think a lot of people use it. It looks kind of cool, but in reality, to me, the results aren't really what I'm looking for, and I think it tends to be long, and it's just not what I like to use. So again, feel free to watch the video. Hopefully it will be, educational for you. If you like the video, please subscribe to the channel. Also, if you like the video, you're more than welcome to make a donation to my cancer ride. I'll have a link in the show notes for that. I've had cancer. I've had radiation. Those people that have cancer, it's not easy for them. If you feel like donating, please do so. If you're in Canada, you'll get a tax-free receipt. So again, feel free to put some money there. It goes to a good cause. It can help a lot of people out. Anyways, let's get going. So before I get going, I'd just like to maybe give you a couple of my credentials. I know a lot of people don't know who I am. Some people probably do. Some people have heard. I know a lot of people in the industry. I've been selling lasers for over 30 years. I was the one that developed how to successfully do Lamicoid plastic engraving, and I was also I came up with a process of how to do photographs successfully on glass when everybody said you couldn't do it. I came up with processes in CorelDRAW so people could successfully do photos. I've done numerous seminars along with writing for articles in our industry trade magazine. I've helped a number of customers by assessing their laser processing settings and helping speed up their production. And I think the most important thing that I tell people is, because I sell lasers, every time I do a demo, I feel like I'm having to come up with new settings. It's easy if if people are always coming in using the same thing, but I find that for me, that's not really what happens a lot of times. I get a lot of people that come in with some pretty wild materials that they want to laser engrave or they want to cut, and I need to know how to assess the proper settings so that I can cut that material properly. So people say, well, how do you know so much? Well, I say, because I screw up a lot. And I think that's really important to remember, is that we don't get good at this unless we make mistakes. And if we make the mistakes, then we want to be able to assess the mistakes we made so we can figure out what we did wrong. So just remember, what I'm going to tell you comes with a lot of experience. And I'm going to hopefully make it easy for you, because I know a lot of people, get intimidated by by coming up material settings, and a lot of people think that, well, the manufacturer is going to come up with the settings. Well, I can tell you right now that the manufacturer settings a lot of times are crap, and I can tell you that because that's 30 years of dealing with their settings, which a lot of times don't work properly. Or they work for one thing, but they don't. They might work for one piece of wood, but we've got zillions of other pieces of wood, and I can tell you right now that not every piece of wood engraves the same as another piece of wood. And you're going to have different settings for photographs. You're going to have different settings for text. You're going to have different settings for logos, and so the successful person is the one that takes a look at what they're doing, and they adjust their laser so that they get the best image that they can with that laser. The other thing I want to stress to you is that I use RF. We sell RF controlled lasers. and to make it, well, there's three different types of lasers on the market, but we normally talk about two. I don't really consider diode lasers really to be, you know, a in this field of lasers. We typically sell, you know, the RF controlled lasers. We do sell glass systems, but glass system lasers don't have the same ability to adjust a lot of the different factors that we're going to talk about today. So if you have a glass tube style laser and you're finding that I say to do this or to do that and it's not working properly, or you don't have that setting, it's probably because the glass laser doesn't support that setting. Because I can do a lot with the RF controlled lasers that you can't do with glass lasers. So just remember, if I show something and it doesn't work on your machine, it may just be because your machine just doesn't have the ability to do that. So, you know, take a look at what we're doing. If you find it doesn't work, well, I'm sorry, but you may not, your system just may not be able to support that feature. But anyways, I'm going to get on with things. Just wanted to clarify a couple of things here, and let's get going. Before we go on and talk about material settings, I want to talk about consistency. And I think it's something that a lot of people don't really ever consider when it comes to the laser machine. But consistency is the secret to always having, like, there's no sense having a material setting if your machine one day is at 60 watts and the next day it's at 100 watts, because again everything is changing, right? So what you want is a consistent setting that's always the same, and this is so important for people to understand. And consistency in the laser machine a lot of times is basically due to, you know, some just general maintenance settings that you need to make sure that you've done in the machine. So things like dirty lenses and dirty mirrors can greatly affect the power of our laser beam, as dirt absorbs a certain amount of power from the laser beam. So if you don't have clean optics, then you're going to affect the power and speed that your machine is generating. Therefore, the settings that you've got for the material settings you've got for the machine aren't going to be right. So if you've got dirty lens and all of a sudden your laser is firing, you know, 20% less because, you know, the dust is absorbing a certain amount of the energy coming from the laser beam, then you're not going to get the proper results. And it's amazing how many times you go into people's operations and, you know, they don't have clean optics. You know, it's the first question we ask when people say that, you know, all of a sudden they've lost power to the machine. You know, have you cleaned your optics? You know, because it's very, very important that people do that. You know, another thing on consistency is to make sure your beam is in proper alignment. So a beam that's out of alignment, you know, might engrave right on one part of the laser table, but on another part of the laser table it may not work properly. And we see a lot of this happening, you know, especially during cutting processes, you know, where somebody's cutting through, you know, one section of the table and they go to another section of the table and all of a sudden it's not cutting all the way through. Okay, so again, you know, the first thing that the technician does for our company is when they go in and they install the machine, they check the beam alignment. And again, if you are doing, if you're having, you know, one of the technician come in and check your machine out, you know, certainly you want to make sure that they do the beam alignment. Once you've done the beam alignment, a lot of times with the machine, you never have to touch it again, but you want to make sure that it's set properly. Make sure your cutting table is level. If the table is not level, then your beam is going to be inconsistent because your material now is not level. So if you focus one part of your material and then you go to another part of the material, if things are on an angle, then you're not going to get proper cutting. So again, make sure your tables are level, your cutting table is level, and make sure that the solid table, if you've got a cutting table sitting on top of a solid table, then make sure that both those tables are level. The last thing is consistency in your material. And And again, there's many times where people call me up and say, well, my wood's not engraving like or cutting like it used to. And I say, well, okay, we go through, did you clean your optics, and is this level and is that level, and how old's the beam, and what it ends up being is they've, maybe their suppliers changed materials, and all of a sudden it's not cutting properly, or it's not engraving properly like it used to. So, again, if you're not getting proper results, the first thing you're going to do is probably call the laser supplier. But you should probably also look at maybe calling your supplier and say, hey, listen, have you guys done anything with this material? Because, it used to be fine, and then all of a sudden it's not fine anymore. So, again, this is really something that you need to consider, because sometimes what ends up happening is that the suppliers change the materials. I've had this happen with MDF. The person calls me up and says, well, now it's flaming and it's burning and everything like that. And then we find out it happens to be that the suppliers change the materials. Maybe they're getting from a different supplier, and again, you just never know. But certainly having consistency in material is very important. So just remember, you want to have clean optics, you want to have good beam alignment, you want to have a level table, you don't want to have any dents in your cutting table or anything like that, and you want consistency in the materials that you're working with. Because if you don't have consistencies in the material, then you're going to have some issues. One of the things I think that people don't really think about when it comes to getting good testing files is actually have some good tools on hand. For example, the first thing that I always have is good testing files. What do you mean by that? Well, I always have a file that has a photograph that works on a lot of different materials well. If you can't find one of those, you can always ask your laser sales rep or go online and see if somebody's offering a file that's a good photo. Having a good photo is very important, because a lot of times it's not the photo that's the problem. It might be the material, it might be the power settings. So if we know the photo is good, then it sort of eliminates one of those main factors that would account for whether the photo is going to come up good or bad. I also like to have a good logo file, something, maybe with some thin lines in it. I like to have some good cut files, so if I'm vector cutting, I'm not just doing a rectangle or something. Sometimes you might have to do some smaller pieces. It really depends on, some of the limitations that you may have in the files that you're working with. So if you're doing a lot of, fine cutting, where you're doing a lot of small contours and things like that, then, it's always good to have a file like that, because you could have the issue where you have lines running into each other. So again, have some good cut files, depending on the type of materials you're working on and the type of files that you want to create. And the other thing is to have some good fonts. Certainly bolder fonts such as Arial, are a lot better than some serif fonts such as Times Roman. So again, it's always good to have some fonts there, because if your job consists of a lot of text, then that's certainly one thing you want to look at and see how the text reacts. If you're doing a lot of text, there's no sense doing photos or logos, because it's different requirements for logos and photos than you would have maybe with text. So again, tailor your testing to tailor your files to the type of testing that needs to be done. Another thing I like to have is a loupe. Loupe is like a magnifying glass. I actually have a wireless microscope too, and this works really well. And a lot of times you may look at something and think it looks fine, but when you really put a magnifying glass there, you can start to maybe see some issues that may be happening with the material, or might be happening with the machine itself. The problem when you're engraving things like wood tends to hide a lot of imperfections in your machine or in the file itself. So it's always good to have a loop so that we can kind of get a closer look as to how the laser is reacting with that material. Have a caliper. There's a lot of times where, I'll use a caliper when I'm testing for curve correction, where if I do a 1-inch box, when I cut it out, it's not going to be 1 inch, it's going to be smaller than 1 inch. So I have to, apply a curve correction so that if I want a 1-inch box, that's what I cut out. So having a caliper is good because, again, it gives you that fine ability to measure things. Sometimes it's also good for measuring you may have a glass that's tapered, and so it allows you to measure that part of the taper where you actually want to put your image on. Measuring tape, again, there's sometimes pieces are really big, so it's always good to have a measuring tape. Another thing, a camera, a camera or a cell phone. Most of us have cell phones with cameras in it, so probably just a cell phone is good. Most cameras now take some pretty amazing pictures, and again, it's very important sometimes to take pictures so that you can keep detailed records of what you've done. Or again, you may want to send something that you've done to a customer in terms of your testing. So again, it's good to have the camera there so you can take photographs and you can keep a record of what you've done. Lens cleaner and tissues. Again, I've already talked about this, but it's amazing how many times I go into people's operations and they don't have, they're not using the proper lens tissues, or they're not using the proper cleaning solution for the lenses or the mirrors. Cleaning materials themselves. Again, there's certain cleaning materials that we use, things like LA Awesome or Mr. Clean Magic erasers. Those are things that you need to have so that when you're testing, you can check to see if the product is good or if it's not good. Sometimes you need to clean the product properly to see if it's good. So again, having the proper cleaning materials is very important too. Masking. A lot of times, we sell 6-inch, 8-inch, 12-inch rolls of masking. Masking is used extensively, when you're cutting out and you don't want to get burned edges, or maybe you're engraving deep and you don't want the staining that's going to happen in the wood. So again, having masking there, sometimes that will help out, if we're looking to get a cleaner edge than maybe what the laser is giving us. Masking tape. Another one is masking tape. We like to use masking tape. A lot of times I'll stick it on products so that I can put, the speed and power settings, DPI settings, frequency settings, so that I can keep a record of the different pieces that I'm working with. And that's very important to, and I'll talk about that later on, but mark everything with the settings that you're using. Don't command it to memory, because if we sort of think we're going to remember it, a lot of times we're not. And when you get as old as I am, things don't stay in the brain very long. So again, very important to write everything down. Masking tape works really well because I'll use a good Sharpie, which is the last tool I'm going to mention here, because the Sharpie allows me to put a good mark on the masking tape so that I can keep records of what I'm doing. So those are some items, some tools that I like to use. I'm sure there's a lot of other ones that people can come up with. And again, these are things that need to be thought about, because if you don't have the proper tools to do something, then you're not going to be able to have 100% acceptance of the materials of the products that you're creating. So make sure you got these items, and if you need to add some more, do it. Previously, I talked about how consistency was very important when we're looking at materials. And what I would say in this chapter is that it's also very important to make sure that we're always assessing the product that we're working on so that we do have the consistency. So, if I take a look at wood, for example, what are the things that can change in wood? Well, we could have we may have tested our material and it was flat. Well, and then maybe we got a shipment in, and now the product is warped. Well, that will change the way that we cut through the product, because we may have to increase, our power a little bit to facilitate the fact that there now is warpage in our material. You could have a light piece of wood and a dark piece of wood together, because again, a lot of times when you're working with wood, you're not working with a solid piece, you're working with strips put together. So this can cause issues, because maybe we tested with a light piece, and then all of a sudden now you've got a shipment in from your supplier, and you've got dark grain there, and you don't have light anymore. So again, yeah, plywood, really common thing that happens in plywood is people having knots. And if you've ever cut through plywood with knots, you know that once you get to a knot, it's not going to cut through like it would normally cut when there wasn't a knot there. So again, you're going to cut everything, you're going to pull that piece off the material and off the bed, and you're going to find that the pieces aren't going to drop out because the knot's holding them together. So again, these are things that you really need to make a look at. And this is why it's always very important that, when you get a shipment in, try not to wait until it's the day of the order, because if it's the day of the order and you pull everything out and all of a sudden you realize there's issues in terms of it's not consistent with what you expect, then you're going to have problems. So it's always very important that we look at our products, and just make sure that we're working with something that's what we expect we should be working with. Because if you sit here and make a lot of settings for different all your materials, and then all of a sudden 6 months or a year goes by, and then all of a sudden the materials for some reason aren't the same, then you're going to have trouble. So again, always very, very important that we assess our product before we put it on there. And that goes really for if a customer brings something in for us to do, right? The first thing we should be looking at isn't, yeah, I can do that. It should be, well, I'm going to take a look at this with a little bit more of an eye, for, as an experienced laser user, to say that, this wood may not support, what your expectations are. And so, and I've had this many times where people come into the office and they bring in some cheap wood, and they kind of think, oh, this is just normal wood. And you go to engraving and you go, oh, this stuff is like, this is horrible. And it won't engrave up properly. So again, we always want to be assessing the product, because we don't want any surprises when we go to do the job. And again, it's very important. I can remember years ago when we were selling some boxes from offshore, and they looked like really nice wood, and then you go to engrave them and it was like, this stuff is bad. I mean, the only way we could make it look nice was we had to sort of stain it inside, like inside the engraved part, just to make it look good, because the wood was so bad. And that's what I say. You can't use settings on one product and then get a new product and assume that those settings are just going to work. So always really important that we assess the materials so that we are not going to have any surprises when you go to run the job. In this chapter, we're going to take a look at how the laser works and some of the characteristics of a laser. This may seem a little bit basic for some people, but again, I think it's important that we all have a good understanding of how the laser works. I'll talk about some characteristics of the laser here. I may brush over some of it. I'll come back to it later on when we're talking about other ways to control the laser when we're testing material. But I'll give you sort of a basic understanding of the characteristics of the laser. The laser is actually an acronym. It stands for Light Amplification by Stimulated Emission of Radiation. And that may sound really cool, but really all it is the laser is just like a light bulb. Or that's the way I explain it, because that's sort of the way I look at the laser machine. You have gas encapsulated in the case of a light bulb inside the glass, and in the case of the laser inside the resonator, if you're talking about an RF laser. And we dose the laser, meaning we push energy into the laser, and that energy causes the molecules, the electrons, to get excited, and they create light through that excitement. Once that excitement is over, then the laser, or in the case of a light bulb, goes dark. And that's how I explain it. I think that's a good way of looking at it. I think it keeps it simple for people. As with a light bulb, our light moves from a resting state, which is darkness or zero energy, and it goes to the excited state, which in terms of a light bulb and normally on a laser, to 100% peak power. And that keeps it relatively simple. The movement, the movement from the resting state to the peak power is known as the rise and fall rate. And rise meaning we're rising to energy, higher energy, and then falling to a low energy state. And that's normally expressed in a wave. If you the rise to peak and the rise to fall back to a resting state is normally expressed in time. So when you go from 0 to 100, that happens a certain amount of time. And then when it goes back to 0, again, that's measured in time. So our rise and fall rate, we have a certain amount of time. And that's very, very important with the laser machine, because that's a big difference between, say, a glass tube and an RF excited ceramic core type laser system. You'll find that glass tubes have a long rise and fall rate time, which is why they run so slow, where the RF tubes have a very fast rise and fall rate, and that's why they can move very fast. There's other characteristics that allow you to go fast, but that's a major factor in allowing you to run fast. If you think of turning on a light bulb and then turning it off, this is really a simulation of how the laser works. So if I go over to my light switch and I turn it on and off, then so if I go here, let's just turn the light off. I go to my light bulb here and I turn it on, off. So that's basically our resting state, and that's our excited state. So again, as I turn it on, turn it off, turn it on, turn it off, that's really how the laser works. And there's a cycle time for the event, and it can only happen in a certain amount of time. So we normally, if you want to go from a dark, like 0 power to 100% power, you have to wait a second. Like when you turn a light on, it just doesn't go light. It takes a second for, the bulb to sort of, create the maximum light, and then it turns off. Okay, and we call this a cycle time. So the faster the cycle time, typically the faster you can move. So when we're engraving, you see this very, very fast, because what you're seeing the laser beam go on and off, on and off. When you're cutting, you're not sort of going as fast. So it's more prevalent when you're actually engraving. So when we're looking at how the laser fires, we can sort of break that down into two processes. The first process is engraving, and the second process is cutting. The amount of that a laser fires when it goes from a resting state to its peak power, and then back to its resting state. Normally, when we're engraving, that's expressed in DPI. When we're cutting, um, we normally talk about frequency in terms of the amount of firing. Okay, so let's take a look at those two processes and we'll break that down so we have a little bit better understanding, of how DPI works and how frequency works. DPI is dots per inch, so it would be the same as a laser printer or an inkjet printer. And if I say 600 DPI, that basically means I've got 600 dots left to right, and I have 600 rows up and down. So in a 1 inch square, and that's why we call it dots per inch, because we've got 600 across and 600 down. If we're running 300, we've got 300 across and we've got 300 down. And typically what you would see in a laser printer is that you would see that the higher the resolution, the better quality the image is. That's not really true on a laser machine, because the dots are a lot larger normally than we have on a laser printer. And it can be very large on some materials, and the dot can be a little bit smaller on some materials. So again, I typically don't engrave anything more than 500 or 600 DPI. I sometimes will even engrave a lot less, but again, it depends on the application. But when we're engraving, the engraving is resolution dependent, meaning that it's this resolution of 600 dots or 300 dots or 500 dots or whatever we're running that dictates how much the laser works in a square inch. And just remember that if I'm running 600 DPI versus 300 DPI, then 600 is twice as slow. It's twice as slow as 300 DPI, or 300 DPI is twice as fast as 600, because now I'm only running 300 dots down, and in 300 DPI. On 600 DPI, I'm running 600 dots. So the laser has to double its amount of dots in an inch. So, it's very important to remember this, because sometimes we'll run at lower resolutions because we don't see an issue in quality, and also the burn allows us to get a half decent image, and we can, if I go from 600 to 300, I just automatically doubled my engraving speed, and now all of a sudden I'm making twice as much money in an hour. So again, it's sometimes, with certain things we don't think about, but again, we'll talk about it later on. But resolution can be very important. The other thing to remember is that 600 DPI is, if I was to engrave 600 DPI image versus a 300 DPI image at the same power and speed, the 600 DPI image, say in wood, is going to be darker than the 300 DPI, because I've got twice as many dots and I've got twice as much burning in that inch square. So again, that's another thing that sometimes it takes. We have to take that into account when we're assessing what type of settings we're going to use. And again, you can see that in the photo below, with just some different resolutions. I've got basically, a darker burn on the higher resolutions and a lighter burn on the lower resolutions. And the higher burn means I can go deeper, and than I can, on the lower resolutions. So again, I might, instead of going twice, at 300 DPI, I could go once at 600 DPI, and they both would basically look the same. At the end of the day, they'd have the same amount of time, and that's really the thing to remember, when you're looking at that type of burn. But again, it's important to understand that. When it comes to cutting, we're talking in frequency, because cutting is
typically done with the vector line, and vector lines are resolution independent, meaning that they're not controlled by DPI. They're controlled by their travel path. And when the beam is firing in a linear inch of travel, we can use the frequency to force the laser to fire more times in that inch of travel. So if I'm running at 1,000 frequency, then theoretically that would be, say, 1,000 dots per inch of travel. If I go to 5,000, now I'm firing the laser 5,000 times. Now, there's something very important to remember on that, is that if I fire the dots too much, then what ends up happening is my laser never really goes from that resting state and gets to the top of its peak power. So, if I'm running an 80 watt laser, let's say peak power is 80 watts. If I've set 100% power, in the settings. So, but because I'm sort of going, I'm not really allowing the laser, because the laser has a certain amount of time to go on and off, as we talked about the cycle time. And if that cycle time is met when we're running at 1,000 frequency, and all of a sudden let's say I go from 1,000 to 4,000. Well, now I'm trying to turn that light switch on 4 times in a normal one-time turn on. Okay. And if you've ever been in your room or wherever, and you start hitting your light switch really, really fast, you never really seem like the light goes off, and it really never goes to black, but it never really goes to a bright white. And this is very important when we're looking at frequency, because this is really what the laser does. It needs a certain amount of time, as I talk about, to go from that resting state to the peak power is full excited state, and then to come back down again. And if we don't give it the opportunity, if we tell it to sort of get 3/4 of the way to light, and then all of a sudden we say, well, no, you got to come back down because we want you to fire again. Well, what we're really doing, and if we had a wave, as you can see from the image here, I'm actually flattening the wave out. So now if I had an 80 watt, I'm really not getting to 80 watts. I might, depending on the frequency I'm using, I might only get to 75 watts. I'm firing the laser more times, but I'm actually not getting the most power out of the laser. And again, this type of setting is very important when we're talking about the laser machine, because a lot of times if I'm doing wood or if I'm doing paper, I'll use 1,000 resolution or frequency, for cutting wood or paper, things like that, because that peak power gets to, if it's an 80 watt, gets that 80 watts, and so I get really good vaporization. If I crank the frequency up, I may start to get some burning. I may not, because now the beam is not getting to that full power, so I'm not getting that really good vaporization. Now, a larger frequency, helps us out maybe in acrylic, because we're not sort of looking to get that really nice clean edge like we would on paper, or wood. So it's better that it gives us the flame polished edge when we run at a higher, frequency. So that's really, something to remember. So, again, if I turn my light off again, and I go over to my light switch here, and if I turn it off, again, I go from nothing to high. But now if I start doing this, and if I do it fast enough, the light really never gets the opportunity to get to its full power. And that's really, something to really understand, when we're talking about frequency. And we'll talk about how the frequency interacts later on with the in the laser machine. Okay, let's talk about power and speed. If you notice the quote I put at the beginning of this chapter,
it said, laser power corrupts your material. Absolutely too much laser power corrupts your material. Absolutely. And it's kind of an adage that I've been using for many, many years. And really what it says is that you always want to use the least amount of power that you can get away with, because anytime you use too much power, you end up having issues a lot of times with the way the power changes the characteristics of the product. And you know, this happens a lot of times. If you take a look at this black granite picture here, you can see that I've overpowered it. I put too much power on it. I remember when I did my first black granite photograph years and years ago, I thought, oh, I got to put a lot of power on here. And what ended up happening was I got a white square. And I got the white square because I just used too much power. So anytime that we use too much power, what we end up doing is that we end up having a lot of dot gain. We might have the material may warp. We may get some overburning that maybe we don't want. We may get dot gain, as we did in the black granite, you know, where the dots just become too big and they just wipe out the whole image. So it's really, really important that you know, when you're testing, you're always in the back of your mind going, I want to sort of get this so that I'm using the least amount of power, but I'm still getting the image that I want to see. I mean, if you take a look at the picture at the bottom here, this is just some black brass coated steel, and you can see how 3% power can change how the line. You notice that the line is there in the top image, and the same image in the bottom. I'm just using more power, and not a lot of more, 3% more power, and you can see that it's basically obliterated the line. And so again, it depends on the material you're working with, you know, how it's going to react to the laser. And so you may be, you know, if you're doing wood, you may not worry so much about it. But if you're doing black brass coated steel or something like that, where, you know, small changes in the power can greatly change the way the image looks. So it's always important that you know, we keep this in mind. The way the laser works really is we're normally adjusting power and speed. So, you know, if I want to make an adjustment, I can either adjust power or I can adjust speed. And adjusting one of those two parameters can either give me more power or less power, or it can give me more speed or less speed. When we're looking at 20 versus 100 for, say, power, that's a percentage of the laser. So if I have a 100-watt laser and I'm using 50% of it, I'm using 50% power. Okay, if my machine goes at 140 inches a second, which it does on the Speedy 300, if I'm using 20% of the speed, I'm using 20% of that 140 inches. So, you know, a lot of times people might come from an old machine to a new machine and try to use the same powers and speed percentages, but it actually may not work because, you know, the math is different, you know, especially if you have a lot more power, you have a faster machine. So again, those are things to sort of, you know, always, you know, think about. The way I look at the laser machine, the way I explain the way power works is I typically look at it from a stove. If you touch an element on a stove very fast, you don't really feel the heat. But if you leave your finger there for any length of time, you're going to get heat. And the laser machine works the same way. Either, you know, I'm getting a lot of power if I'm not using a lot of speed, or I get minimal power if I'm using, you know, a lot of speed. So again, when we're running the job, we normally run at 100% power and 100% speed. Anytime I need to have more power, the only way I can achieve power when I'm running at 100 and 100 is to lower the speed. And that's sort of simulating my finger on that element being there longer. And it's really just those two parameters. There are other things that we can do when we're working with materials, but those two parameters are really the two main settings that we can change on the laser, and that relationship is normally an inverse relationship. So if I'm running a laser that's 120 watts power, and I'm running a 60 watt laser, and I'm doing wood, say, well, the 120 watt is going to be twice as fast as a 60 watt because I've got twice as much power. So it's very important that if you are looking at production, that you try to get the most power you can get for the material that you're working with, because if you want speed, you need power. So, it's always, it's a trade-off. The quality is always going to be the same, typically. But what's gonna change is how fast you can produce the product. And then if you're, if you want to, if you're producing 100 images a minute on a 60 watt, then you can produce 200, images, on a 120 watt machine, and therefore your cost of products goes down. If you're charging, by the hour. So again, it's always very important to make sure that we understand the power and the speed and how they relate to each other, and we don't overpower product. Too many times, I mean, people complain. I remember how many times people complained about red on white plastic, and how the white got contaminated by the red. Well, a lot of the issues there were just because people were using too much power, and then the material would warp. They get a sticky residue, and I kind of said to people, we don't need a lot of depth. So why are we trying to achieve a lot of depth? Right? Just you're looking for a contrast, so you just need to take that red layer off, and by taking that red layer off, you're generating a minimal amount of residue. So it's very important that when we're testing for the look that we want, but we're also testing for how the materials are reacting to the power of the laser. As I mentioned previously, one of the biggest challenges we have is if we use too much power, or for that matter, we don't use enough power, then the dot that we create may not be big enough, or may be too big. And typically I refer to this the same as we would in the printing industry as dot gain. What is dot gain? Dot gain basically is when we laser a dot, it's the spot size that creates that dot size hits the material at a certain width. Now the heat of the laser causes that dot to increase, and it really depends on the material that we're working with, how much that dot will expand. I used to do a seminar in Vegas, and it's on my YouTube channel, where we talk about different materials and how certain materials will gain dots more than other dots. And again, this is something that if you really want to start looking at your material settings, then you start to classify the materials so that when you go to laser engrave a certain material, then you sort of have a good idea of where to start. I don't want to get too technical on here. I don't really need to. What I need you to understand is that as you increase the power of the laser, the image that you're creating gets bigger. And I showed you how a photograph on a piece of black granite, became almost a blob because we were using too much power. And you can see that in the image below here. I've got two images here. One is where I've got a rectangle, and I start out with good power, and then I start to decrease the power, and then you can see the actual gold foil there because I'm just not generating enough power. And then as I go down, I'm adjusting the power on the fly as I go down. And you can see that as I traverse and I increase my power, then my burn goes good. And I normally can just look through the window of the laser and I can figure out, well, that's a good burn there. And if I want to double check, I can pull it out. The second image is a couple of raster and vector lines, and again you can see how they adjust. So whether it's a vector line that you can see the three lines, the power starts to get more, and the line becomes wider. And it's the same on the raster too. And this is really something to remember, because as I mentioned, if you're looking for fine detail, you're not going to get it if you use too much power. Okay, but if you're in wood, you may want to do that and get a wide image, and then you can do it. But dot gain is very important to consider, and if you've got too much power, then your dot gain is going to be too big. And in the next set of images that I'm going to show you, you can actually see what a customer has given to me. And this customer, I remember years ago, he wanted to do a nice image for the CFB base in Ottawa, and he kept getting a blob on his black anodized aluminum. So I said to him, I said, okay, well, send me the image and I'll give it a try on some of my aluminum here, and the anodized aluminum. And so he sent me the image, and I asked him what he was using. He gave me the power, which was 100 power and 100 speed, because that's what the manufacturer said to use. And again, as I mentioned, I never listen to what manufacturers do, because a lot of times they don't know what they're doing. But you can see the progression of the four images. So the first two images here, you can see at 100 power and 70 power, the image is getting better, but I still don't have the image of what he was looking for, because he actually has a secondary image that's kind of blended in the background. And if you look at the next two images, then what you'll see is you'll see at 50 power, and then you'll see at 43 power. And you'll see how good the image, even at 50 was pretty good, but at 43 it's even better. And a lot of people, when they're doing, when they're adjusting their power and speeds, they might do 50 or 40 or something, but who does 43? And this is why you really need to just, depending on the power or the material you're working with, these minor changes can greatly affect the way the image looks. And you can see that the Canadian flag image in the background shows up at those lower powers. So all the customer was doing was he was just using the wrong power and speed. He thought he was having issues with the photograph. Something was wrong with his laser, and he wasted all this time because he didn't test the material properly. And I'm going to get into the testing next, but it's just, I can't go over this enough with people to let them know that a lot of their problems is just in the proper power and speeds to create the appropriate image. And just remember that certain materials react differently to the laser than other materials. So you can't just assume if it works on one, it's going to work on everything else. And that's why I tell people that when I create a wood image, I'm not just doing, a one piece of wood and an image and that's it. I mean, there's so many different species of wood, and again, do you have a photograph? Do you have an image? Do you have fine text? I mean, there's just so many things that go into it, that you really need to have a number of different settings. In this chapter, we're going to take a look at how to actually test materials. If you remember earlier in this video, I talked about having a number of different testing files. And I think this is very, very important. These included just a rectangle, a intricate logo, small text, and a photograph. These four typically will get most of the different types of files setups that you're going to get when you're working with the laser machine. I always start out with the rectangle first, so we'll start off the discussion with that. The first thing that we have to make up in our mind when we're actually testing materials is what speed are we going to go at? Most of the time, I'm going to go as fast as I can. And the speed and how fast you go, that really is dependent on the customer. Some people want to go at 100% speed. People want to go at 80% speed. Again, some people want to go at 100% power. Some people would rather just stay at 80% power. This is really up to you as the operator of the laser, and what you feel, how far you want to push the laser machine. If you decide that 100% speed and 100% power is adequate for what you want to do, then my suggestion is always, this is really where we're going to start. We're going to start at these types of settings. So for example, if I'm doing a piece of wood, I'm going to use my setup file. In this case, it's going to be just a black rectangle, and I'm going to send it to the laser machine, and the power and the speed are going to be 100 power and 100 speed. And I'm going to test this and see how deep the engraving goes. And this will, once I sort of get a good depth setting and what I feel is the depth that I want, then I will take my other three logos and I will start to do some testing with them, and see how that power and speed affects how those test files look. But we always want to start out with the black rectangle. I know it sounds a little bit simple, but it really is in my estimation. The thing to remember when you're testing with the black rectangle, and normally what I do is I normally do like an inch by an inch type or half an inch by half inch. It really depends on what I'm etching and how deep I want to go and how much I want to see of that depth. Normally, even for me, half an inch by half an inch is fine. I don't want to spend a lot of time on it. And normally with things like wood and plastics and things like that, like laserable plastics and all that, acrylics and all that, we can get away with a pretty good setting just with that small rectangle. But we want to use this, and the thing to remember is that when we etch the black rectangle into the product, if we stop the machine and we take a look at that depth, then if we have a certain depth and we say, I want to get double the depth, well, then I just run the logo twice. And if I run the logo twice at 100 power, 100 speed, if I want to run at one pass now and get the same depth that I've got with the two passes, then it's going to be 100 power and 50 speed. As I mentioned earlier, typically the laser is basically an inverse relationship. So as the power goes up, the depth goes down. Okay, or sorry, proportional relationship. So what ends up happening is that if I go at 100% power and 100% speed and I want double the depth, that's going to be 100% power and 50% speed. If I want 4 times the depth, then I would go at 100 power and 25% speed. So again, it's easy to figure that out. And like I said, if you do one job at 100 power, 100 speed, and then you want to see how deep you're going to get on the next pass, then you can just run at 100 power and 50% speed. Now, just a side note on that. Normally, when I'm testing, I try to push the material right up against the rulers. So if I do have to take the piece out and take a look at it, or get a loop out to take a look at it, then when I put it back in again and I do press the repeat button, everything's going to be pretty well lined right up again. So I don't have to worry about, this has happened to me many times where I pull something out and put it back in and maybe I didn't push it right up against the rulers and it'll be off a little bit. So again, always important to put it in. But the thing we have to remember also is that certain materials don't allow us to go at 100% speed and 100% power or some sort of facsimile of that. There are materials that I've etched before where I can only go at 30% speed, and then I need to adjust the power accordingly for that speed. But normally 100% power, 100% speed, or 80% power and 80% speed, or whatever your upper echelon limit to whatever you want to run the machine at, always work with those settings and start there. You can always, like I said, press the repeat button and do it again, and that'll give you a good estimation on the depth of the engraving. But all I do, as you can see on the screen here, is really just a black rectangle, and that's all I work with. If I'm cutting, I'm just using with the black rectangle. Well, I'm using a rectangle, sorry, just with a red outline. And all I'm going to do is I'm just going to keep cutting that rectangle until I go through the material. And then once I've got the basic settings, then I'm going to put in my more intricate logos or whatever I want to cut my test file with. And then I'm going to use those powers. I may have to tweak it a little bit, but again, just working with the rectangle is a great way of getting us, 95% of the way that, well, where we need to go. Okay, so don't be afraid to just use the rectangles. It's very simple to get our settings, and I use it all the time, especially with materials that I'm not used to or materials maybe I've forgotten about. So it's a good way for me of starting off and getting some settings, and then I can always use the more intricate logos or the photos or whatever I want to work with for a test file, and we'll see how they work on the same material. Here's the two images that I typically use. As you can see, they're just simple rectangles. One is a cutout rectangle and one is an engraving rectangle. I know this may seem a little bit simple, but really, for me, most of the time, this is all I need to produce the required results that I need to test my material, and I can normally do it quite well with these images. You can see on the screen here that I've got a test file that I'm going to laser engrave on the samples video that's going to come up next. You can see that typically I like to write down the actual power and speed and the DPI that I'm using. This is good reference because many times you might be doing a number of different test pieces, and it's always good to keep track of what you're doing. Trust me, there's many times where I haven't, and then you kind of kick yourself because you can't really remember what you used. So it's always good to indicate the power and speed that you're using for the example. It's also good to have a large rectangle along with text because both of them are going to look differently. The rectangle is going to give you a good indication of what the depth's going to be because you're going to see a larger area. In terms of the text, you'll be able to get a little bit better idea with the smaller images, how that same depth is going to look with the text. And what you're going to see as we talk about this is that larger areas are going to give you a perceived deeper engraving, while a lot of times smaller text like this isn't going to give you the same sort of depth perception that you would normally get. And this is important because what you're going to find is if you use too much power on certain types of images, they're not going to look nice. And sometimes we might actually have to run two different power and speeds for the two images that are actually on the screen. For example, I may run the rectangle at one power and speed, and I may run the text at a different power and speed. And we'll go through this as we're doing the testing. But it's very important that you put these numbers in here just for references. So in our first example, you'll see here I've got a video going, and I'm engraving the text along with the rectangle. As I indicated before, I'm running 100 power, 100 speed at 500 DPI. And we can run through this engraving here, and you can see how the depth is going to be a bit different looking than the text will be. This is real time. It doesn't take that long to do, so for a lot of us, a couple of minutes, and a lot of times you can get your settings right away. So I've zoomed in on here, and you can see 100 power, 100 speed, and one pass. And the one thing you can notice is that the depth of the text, the depth of the rectangle looks a lot deeper than the text. And again, it's just because there's more area for the rectangle than there is for the text. So if we want to go double the depth, all I need to do is run the 100 power, 100 speed setting twice. Or if I wanted to, I could go 100 power and 50 speed and one pass, and the look will be exactly the same. In this case here, I'm going to run 100 power, 100 speed twice. So you can see I'm doing it once, and then I'm going to hit the repeat button, and I'm going to do it twice. And this is an important thing to remember, because both are going to do the image at the same amount of time. It's just a question of, do I want to do it with 100 power and 50 speed, or do I want to do it twice at 100 power, 100 speed? And that's really personal preference. Sometimes it's a little bit better with the two passes. You'll get a little less staining. So you can see the image here. You can see I've got double the depth with 100 power, 100 speed twice. But you'll also notice that I got some staining on the image on the right as opposed to the image on the left. And again, this is really something that we really need to consider. And it's what I talked about a lot of times, is that if you use too much power, you're going to get a lot of, you could get a lot of issues with staining or with warping. In this case here, I'm getting more staining. And the question really is, am I really getting an image that looks the same or different?
Seeing we've done one testing with 100 power, 100 speed, two passes, let's see what happens when we do 100 power, 50 speed in one pass. You can see from the testing window here that I'm actually running and I'm getting a similar depth that I got with 100 power, 100 speed at two passes. But you'll notice in the close-up here, I've actually got more staining. And this is something you'll see happen on a regular basis if you try to use too much power in just one pass. A lot of times you're better to try to run two passes, in this case 100 power, 100 speed, because the end result is you'll get less staining than you would get with one pass at 100 power and 50 speed. So very important to remember this. And again, I point this out just so that you can see that this is a different way to look at the material. So just like with the engraving of the box, I'm just going to use the same box, and I'm going to put a red cut line there, and I'm going to cut out the box. I'm going to use 100 power and 1.2 speed to go through the material, and let's see what the results are. You can see that I've got a nice box. Kerf is nice and small, and I've used the 100 power as my power. So let's turn over the piece and let's see what we've got. You can see it comes out nice and easy, so I've cut all the way through. If I take a look at the edge is nice and clean. Remember, this is an aldered style wood. I've got a bit of staining on the back. This isn't really more back reflection as opposed to more just stain that's floating around. But let's try raising up the wood. I raise the wood up on some of the pieces that I've cut out just to give me a little bit more height. I'm going to do the same setting, and let's see how the piece looks. There's the cutout, drops down a little bit. Let's open the lid. Let's take a look at the piece. You can see that the back is nice and clean. So just by raising up a little bit, I get a cleaner back. So let's try a little bit faster speed. This is just a 10% faster, or 0.1% faster. And let's just see what happens. So this is 100 power, 1.3 speed. I'm cutting through. Pieces been cut out. It's sitting on top of the table. It's not raised up. I'm going to lift up my piece. Notice that the piece hasn't released from the back, which is kind of nice. You can see I get a nice clean back. And again, this is really a nice, nice cut that we've got with the laser machine. I'm not one to sort of, this setting I may not use, just because I want to have a little bit of a little bit of extra power for uneven pieces, in terms of thickness and that. But certainly, it's important that you get the settings that are right. Let's get a nice clean back, because in this case, I don't really have to do any work. So using the two boxes really is very easy for me to get some basic settings down for the actual test that I want to do. Again, we can do some more sophisticated tests, and we can use some different testing procedures better. But for me, the box is it's just very simple to use. Again, I can put half-inch box there on a piece of material. Within about 15-20 seconds, I've got good speed and everything like that. And again, if I need to tweak it, I can run it twice. Or if I need a little bit more depth, maybe I'll go from 100 power, 100 speed down to maybe 80 speed, just to get a little bit more depth. But the nice thing is that the box gives me fast results. If you were doing the color wheel, well, you might be there forever. And like I said, sometimes you get a little bit too wide of an area with the color wheel, and you've got pieces running into pieces, and it just becomes very, very hard to sort of, for me anyways, is to do a proper testing. I just like to use the rectangles, and for basic testing, it's a great way to get some really fast results. And like I said, when I'm in doing a demo, I got to get fast results, because I don't want people hanging around while I try to figure out what I'm supposed to do. So this way, fast results, and if I need to tweak anything, I can do quick tweaks. But small boxes I'm cutting out, small boxes I'm etching out, uh, allows me to generate a lot of tests in very minimal time. Now that we've used a black rectangle to test our engraving, and we've used a red rectangle to test our cutting out, let's take a look and see if our hypothesis that if we use two passes, that it's actually double the depth of one pass. If we take a look at the image on the screen, you'll notice that I've got two logos that are exactly the same. The difference in the two logos that I've lasered is that one is being engraved at 100 power, 100 speed in one pass, and the second one on the right is being engraved at the same power and speed, but two passes. And the results, as you can see below these test samples, is the one pass is producing a depth of 7 thou, and the logo on the right, where I'm running two passes, that depth is 14 thou. So what it goes to show you fundamentally is that if you want to double your depth, all you really need to do is run the logo twice at the same power and speed as you did the first time. And this is pretty basic in terms of looking at the laser, and it's fairly simple that way. Um, so, I mean, I could, if I wanted to, run one pass at 50 speed, and I'm going to get the same results. Because the way the laser works is that I have a certain amount of power, and that power gets me down to a certain depth. And then if I run it again, I'm just going to get double the depth. If I want to run at one pass, I can go 100 speed 50, 100 power 50 speed. And really what I'm doing is I'm just going half the speed, which basically means I'm doubling my depth. And it's basically very simple when you're looking at it that way. And that's really what this example shows you. And the same can be done for cutting out. If you cut at a certain power and speed, and you only go, say, halfway through the material, then you can either run two passes at the same power and speed, or you can half your speed and with the same power, and you'll go all the way through the material. And I've done lots of tests over the years, and it's pretty simple. It's pretty well bang on. This is what's going to happen. There's depending on the material you're working with, there's a, some aren't exactly that type of relationship. But again, it's a quick way of doing something and allowing you to quickly say, okay, I've gone seventh thou, but I want to go 14. So really all I need to do is do two passes or do one pass. And instead of going 100 speed, I'm going to go 50 speed. Before we move on to the next section, I'd just like to point out an example here of what is maybe not obvious, or maybe is obvious to everybody, but maybe we don't really think about it. Is you can see that the image on the left, which again is just the one pass, it's lighter than the image on the right, which is two passes. And this is just because I'm generating more power for the two passes than I am for the one pass. And it's those two passes that's creating the darker image, because I'm creating more flaming, I'm creating more residue, which is just in this case of my wood is making it darker. And a lot of people typically like a darker image, and again, that's why a lot of people might engrave deeper than they would lighter. But it's sort of why fundamentally I tell people you need to have different settings depending on what you're engraving. So you might have one, as I mentioned before, is you may have one setting for a logo and you may have one setting for a photo. In the next section, I'll go through why too much power might be detrimental to the way your image looks. Um, and it boils right down to the fact that we're just using too much power and we're just creating an image, the image is getting too dark, and we're removing too much material. And it's very important that you see this, so that when you're doing your settings, you're sort of, you have this in the back of your mind when you're evaluating, how your image looks and what you're looking for in terms of the best looking laser engraved image that you can produce. So in this section, we're going to take a look at how the same power and speeds we used in the previous chapter are going to relate to the photographs that I'm going to do here. Just remember, you saw it come up, but I'm not going to get into photographs too much in this tutorial. But I always tell people that beauty is in the eye of the beholder, and what that basically means is that what I like isn't necessarily what you like, and vice versa. So it's always critical that you sort of keep that in the back of your mind, because sometimes you might think you've got the best looking photo and then somebody takes a look at it and says, well, I really like it the other way. So just remember that when you're producing any image. Now you can see that the first image on the left has been done at 100 power and 100 speed. And then you can see the second one on the left is 100 power 50 speed. Now I could probably have asked most people in the previous chapter which power and speed they like the most, and they're probably going to say 100 power and 50 speed. Gave us a fairly nice brown image, good contrast. But as you can see in this photo, it just doesn't really do, it's just overburned for the photo. And the photo just doesn't look very good. And this is really important to understand, is that this is why I say you can't always have just one setting. You've got to have a number of settings. And this is why I always carry different, logos and photos and text and that when I'm doing testing, because each one is going to show a little bit differently depending on whether you're going to do the photo or you're going to do the logo or you're going to do text. Now, if we move to the third logo, you can see that I've actually lowered the power down to 70 power and 100 speed, and actually it's a pretty good looking image. The fourth one, which is the same power and speed, um, is looking good. But what I did in the case of the text was I actually used 100 power and 50 speed for the text. And this sometimes is the way that I sort of tell people, if you're really looking to do the text the way you want it and the photo the way you want it, you may have to have two different settings in the same job. And this is a perfect example of that being applied here. I've got 100 power, or sorry, 70 power and 100 speed for the picture, and that gives me the best looking result. And because I want a little bit more of a brown image on the text, maybe a little bit more depth, I'm going to actually do 100 power and 50 speed for the text. So, I might have the photograph in black, and I may have the text in red, and I'm going to assign different power and speeds to the two colors. And you're going to find as we talk about this, and maybe not necessarily in this tutorial, but in future tutorials, is that sometimes it's better to use multiple colors and assign different power and speeds, because at the end of the day, you're going to get a better looking image overall. Again, you could just go with one setting here, but as you can see in the third example, I'm using 70 power, 100 speed, and that text for me really just isn't bold enough. And therefore, I would prefer to have a little bit more depth of text and a little bit browner. So again, I would probably want to use, as I indicated here, higher power for the text and lower power for the photo. So very important to remember when you look at these examples is that we're not always going to use the same power and speed in our job. We may actually use 1, 2, I've used 4 or 5 before. But again, it's really important that we understand that you sometimes need to use different power and speeds on the same material depending on whether you're doing a logo, just text, or when you're doing a photo. Although I like to use the black rectangle for engraving for testing, or the red rectangle outline for cutting, typically there are some times where I do use multiple colors for engraving. And I think probably the most common product that I use this on is on Thermark. And that's because a lot of times you spray the product and then you laser etch it, and then you got to clean it off with water. And the problem is that it becomes very difficult to clean off a small spot that you've engraved without affecting the rest of the painted area. So a lot of times when it comes to Thermark testing, I'm going to run 8, 10 rectangles, and I'll run a bunch of different maybe I'll have one power and I'll run a bunch of different speeds, or I'll run one speed and I'll run a bunch of different powers, and then I can etch them all at once, and then I can rinse off the whole piece, and then I can visually see which one, hopefully, which power and speed work the best.
In the image on the screen, you can see that I've got 3 sections saved into a Corel Draw job. The first section, which is the one at the bottom, is telling me that I'm running on a Speedy 380 watt. I'm running at 500 DPI, and the speed is going to be consistent through all the colors, and it's going to be 50. Now, if we look below that, you can see that I've got 11 colors listed, and they go from black to yellow, and then there's a power listed for each color. So the black has 50, the red has 55, the blue has 60, and so forth until I get to the yellow, which has 100. And this is basically going to be engraved all on one of the tiles that has been sprayed with a Thermark spray. Now the actual settings that I put into the job control or Ruby software is listed at the top here above it, and you can see that I've got the 11 colors listed. They're all going to be engraved. I've got the power increasing as we get to yellow, and you can see that my speed is consistent and my DPI is consistent at 500. So again, this is important. And again, the nice thing about this is that you can save this. You can save this setup, and you can save the parameter file. And again, we can reuse this in other situations. You can see the tree listing on the left there. You can see I've done the colored block 50 speed parameter, saved that file in with the settings. So again, if I want to use it again, I've got it there. And the nice thing about it is it can be copied and duplicated, and then if I want to use it for something else, I can modify it and then save it as a different name. But again, this is really a simple way of doing multiple power settings or speed settings on a material where we need to do it. And like I said, in the case of Thermark, you know, I need to do that because I don't want to be consistently wiping off one power, because I'm just going to make a mess and I'm going to destroy some of the area that I don't want to destroy. So doing it this way is far better. And you don't need a large block. I mean, really all we want to try to do when we do this is get a setting that's relatively close to what we want. A lot of times you might see 3 settings might give us a pretty good you know, setup for our material. And then, you know, if you want to test more, then you can say, okay, well, let's red and blue and dark blue look the best, so let's run those 3 and see what they look like, and you can make some bigger images of those. But the nice thing about using 11 is that it allows us to throw away, you know, some settings that may not be perfect, and it gives us the ability to run 11 all at once. And again, like I said, I don't like to do this on wood or things like that. I think my previous example is better. This is really just for some of those materials where we really need to run multiple colors at once. The next image on the screen is the actual tile sprayed with a Thermark and laser engraved. And you can see the imprint of all the colors and the settings that I had in the previous screen etched right into the Thermark. As you can see from the next image, I've actually cleaned the tile off, and you can see that there's a pretty good adhesion now on a couple of the colors. Certainly black, red, and blue are certainly good. Maybe the dark blue might be good also. But again, the nice thing about that is I sort of eliminated a bunch of different of the colors that, you know, I might have thought might work. Now I'm down to 2 or 3, 4 colors, probably in this case, probably 2. And I'll use those now if I need to sort of fine tune the actual settings to make sure that everything works properly. But that's really the way that I normally use what we call a color box here to allow me to run multiple colors in the same job with the same power and with the same speed and maybe different powers, or vice versa, maybe the same power and different speeds. As we did with engraving with the different colors, we can do the same thing with cutting. In the above image on the screen here, you can see I've got a screen capture of Corel Draw. I've got a bunch of color boxes set up. Again, they're outlined instead of a fill. The power's consistent. It's being done. I've listed the laser speedy 380 watt, and it's 1,000 hertz, and that's consistent. The one thing that changes is the speed. And again, you know, if you don't want to use my method of just doing one rectangle at a time, and you just want to run, you know, 10 or 11 or however many number of boxes at once, then you can easily use this example. It's quite easy because all you're doing is deleting the fills and putting in the outlines. In this case, you can see that I've gone from 1.5 speed on the red all the way down to zero point 0.6 speed for the yellow. And this is a good way of doing a whole bunch of cuts all at once, and then you know, assessing each cut to see, you know, what goes through and what's the cleanest. And again, you can do this if you want. Again, that's up to you. But the nice thing I like to sort of just impress on people is the fact that the nice thing about doing this is that I have listed everything that's being done here. Again, you can see that you know, the black is going to engrave at one power. Well, it's going to engrave at one setting, and then the red and the blue and that are going to cut out. So the piece that I'm going to bring out of the laser is going to be marked. And again, that's nice, you know, and from the fact that you know, a lot of times, you know, we do a whole bunch of different samples, and then we sort of go back to them and say, ooh, which one was which, and I can't remember which one I used, and then you kind of got to start all over again. This way, everything's marked, and then that way, it's easy to go back and see it and remember what you've done.
Sometimes what you're going to find is that when you're working with certain materials, in this case, black lamequite, you're going to find that the preset that you may have for that material may not necessarily always work for every job that you do. If you take a look at the ruler here, and again, I like to use the ruler because I do use this on a number of different materials for testing purposes. You'll see that I've got a nice thick logo, some big text. I've got some really small text, and I've got some thin graduations, you know, for the ruler markings. And again, if I was just to run this job at full speed, and which I normally would, you'll notice that the small text and the graduations don't engrave as well as the large text and the larger logo. And this is really just because the laser, it just doesn't have enough time, like a dwell time, where the burn is going to penetrate the material enough that you're going to get a half decent spot. And so what we need to do in this case here is we need to actually split the logo up into a couple of different colors, and we're going to assign different powers, well, in this case, probably just different speeds, to the actual colors that we're working with. And the beauty of this is that it allows us to still run one job, and we just have two colors running. So again, I'll go do the black first, as we've got in the logo above. Then I'll do the red, and then it'll do the cutout. And again, what you'll find when we look at this example is the red will go slower than the black. And you know, the job doesn't become that much longer for the most part. And a lot of times, even though we're doing it in a couple of different steps, it's still one big step. So I can fill up the bed, you know, with this design, and I can press the button, and then I can sort of just, you know, do some other things while it's engraving, even though it is processing the multiple colors. So again, you know, again, nice little file to have to allow us to assess the material we're working with. And I think this is one of the important things that I stress to people, is that you don't always have one setting for one material. There's always going to be cases where you need to have more than one setting for that material. In this first window here, you can see that I've got a ruler that was laser engraved at the bottom, and then I actually have the artwork that I used. This is a traditional way that we would normally have done, say, a job on black lamequite type materials. The black would be used for the engraving, and the red would be used for the cutting. Again, we'd have two different settings, one for each process. You can see from the drawing that the larger characters in the logo were fine. However, when we look at the smaller text and the graduations on the ruler, there's inconsistencies there. And again, this job wouldn't be acceptable if we were selling it. So we really have to come up with a different way of processing this, and what we'll do is we'll use different colors and with different powers and speeds to be able to make a better job of this drawing. In our second example, you'll see that I've basically taken the problematic areas that didn't engrave properly and made them red. And what I've done is you can see from the engraving that now that I've used different power and speeds, I actually have a better process where I've been able to use the black for the larger areas, and then I've been able to use the red for the smaller areas. I brought in the screen capture of the actual settings for the job control software, and you can see that the normal preset would be 70 power and 100 speed, and I'm 90 thou out of focus. For the red, though, I've dropped the power to 55 and I dropped the speed to 30. And again, as I mentioned, the slower speed allows the laser to have a little bit longer dwell time and create a more well-formed dot. And this is typically issues that you'll see when you've got really small or thin areas. We just don't have enough dots being created in a line that you'll need more slower speed and which will generate a little bit more power to get those smaller areas. The easiest test that you can do to prove this would be to do a horizontal line and a vertical line and run at, say, the 70 power and the 100 speed. And what you'll find is that the vertical line, which is like the thin graduations of the ruler, just won't engrave very well. The horizontal line, because you're just moving in the one direction all the way across and you're firing constantly as you move across on that horizontal line, that line will be consistently at the same thickness and will look proper. There is another way that we could approach engraving this ruler. We could actually do the typical logo in black as we're showing on the screen, and the smaller areas in red. However, for the graduations for the ruler, we could actually use a light vector setting. You can see in the settings below, I've actually got it set up where the black and the red are the typical settings that we used previous. However, for the graduations, which is the blue color, we're using a lighter power and a faster speed to give us a lighter etching for the graduations. And if you look in the video that comes after this, you'll see the actual process working. If we take a look at the ruler engraved at the bottom of the screen here, you'll notice that the engraving is very good. However, the graduation lines, although they typically look pretty good, there is some wider areas at the tip where the laser is sort of gone in and then stopped and then proceeded to the next segment. We can easily fix this, and the way we do this is we go out of focus. To fix this issue, what I've done is I've actually put another offset, Z offset, in the actual cut. As you can see from the image on the screen here, I've got my cut setting now is the Z offset is 0.09 inches, which basically means that I've taken the laser out of focus a little bit, made the beam wider, and as you can see from the photo, I get a lot better cut or a vector mark when I'm actually vector engraving, or in this case, just a light vector cutting on the actual artwork. So again, I've got a perfect image the same way I had earlier, and I'm just doing it a little bit of a different way with two raster settings and one vector setting.
Well, I think that's concludes this video. Certainly we've spent a long time. This is a little bit longer video than I thought we were going to make, and certainly one of the longest ones I've done. But I think it's a lot of information that I wanted to get through to people so that you can get a little better understanding on how to test materials and making sure your laser is consistent in terms of the power it's putting out. You know, I'll probably be doing some videos in the future, you know, that'll look at some of the special setups that I've done in terms of testing. And again, if you have any questions or you want to see some, you know, items, feel free to leave a comment, you know, in the field below. Remember, if you like the video, click the like button. If you want to get you know, information when the next videos are coming, then subscribe to the channel. And if you like the video, please do a donation to the Ride for Cancer. I have left a link in the show notes, and certainly you know, that will help me. I don't really collect any money from the site. It's nice if I can pass on some money to some people that are definitely in need. Anyways, have a good day and keep laser engraving, and we'll talk to you soon.